So question 6, and we're given a function is 2 tan x over the domain negative pi by 2 to pi by 2. We're told that g of x is the inverse of f, and then we're asked to define the rule for y is g of x. So a lot going on here. I think the examiners would probably have been better off leaving this second line till part B, where we actually sort of get involved with g of x. Back up here, really, we just want the defining rule for the inverse of this function. So if we kind of treated this as y is equal to 2 tan x, then down here we swap x and the y round and then rearrange for y and say it's g of x, which is the inverse tan of a half x. That seems pretty quick for 2 marks, so I'd probably pop in that the domain for the inverse function is x is all reals as well there. Obviously, if we substitute x as any value between negative pi by 2 and pi by 2, y is going to be all real values, and then the range of this becomes the domain of our inverse. Anyhow, so far so good. Then we move on to part B. So by using implicit differentiation, show that g prime x can be written in this form. So we look at this and think, oh, ugly. Just as a note, the Australian curriculum has calculus of inverse trig functions in it, but the WA examining body took it out when we wrote our courses. So as a result, we don't have a derivative of this on our formula sheet. What we do have is the derivative of tan x. So the first thing we'd probably do is rearrange this into the form a half x is tan of g of x. So kind of going back to where we started pretty much. And when we differentiate this implicitly, then x over 2 becomes a half, and then tan of g of x, here it is on the formula sheet. So we just pop it down, g prime x squared g of x. But then we know g x squared on the formula sheet as well, a few pages further on, is a 1 plus tan squared. So that would be our next line of working. And then up here we know that tan of g of x is a half of x. So that tan squared g of x will be x squared on 4. So then when we try to rearrange this line for g prime x, we leave the half alone. And we're going to divide by 1 plus x squared on 4. So that comes over to the other side, and here we go. And then it's really just a matter of tidying things up. If we double the top and bottom, we end up with g prime x is 2 over x squared plus 4, which is in the form the examiners wanted it. So we're good to go there. Over the page, part C. Then now we have to show that this expression can be expressed this, and we're thinking, partial fractions, here we go. But it's not just determine the values of Q and R, but it's show that this expression can be expressed in this form first, and hence determine. So they're really telling us what to do here. We're going to earn our 3 marks. Anyhow, here we go. So we'll take this expression, start off with this one, and then cross multiply by x minus 3x squared plus 4, and then expand out the top and show that we've got a quadratic upstairs, and hence the expressions will be equal when the denominator here, which is r x squared plus qx plus 4r minus 3q, is equal to 3x squared plus 2x plus 6. And then it's a trivial matter to spot that r must be 3. The q must be 2, and then we better just check that 4r minus 3q gives us 6 for completeness, and when we do that, sure enough it does. So there's a nice little 3 marks. Then we're going to scroll on down, and there's a massive amount of white space to carry on there, and then we kind of squash D into the bottom third of the page. Anyway, our job now is to determine the integral of the function that we just split into partial fractions. And if you did part B, correctly, then this is going to be a dream, because basically we spot that we're just anti-differentiating the function, the inverse function here. So we know the integral of, or antiderivative of this function is simply tan minus 1 of x on 2. This fella is just a simple bit of 3 times the log of the denominator here. I think I maybe called the wrong thing upstairs. Anyway, let's keep going. 3 log of x take 3 plus c. And we think that's a sweet little 4 marks there, isn't it? But if you didn't get part B and get this part out over here, then good luck on this one. So I think quick candidates would have gone really well or really badly on this question.